Good morning, everybody, and welcome to the IAgrE 2023 conference, Agricultural Engineering Feeding the Future. Thank you all for giving up your time and joining us today. We have a great conference lined up with some fantastic presenters from a broad cross-section of our industry, but with one common theme, and that's sustainable food production. Before we start, I just want to explain how the event will work today. As usual, everybody will be put on mute apart from each of our presenters. After each presentation, there should be time for a few minutes of questions. If you could please log your question in the chat function, ideally starting with the letter Q or the word question, just to make it easier for us to identify, that'd be useful. If we don't have time for your question, we will endeavour to capture it for the panel discussion at the end. We're not planning a break before lunch, but we will stop early at 12:10 for 30 minutes. Our final presentation will then begin at 12:40, followed by the 40-minute panel discussion at 1:10. The panel discussion will be hosted by our Landwards editor, Mr. Andy Newbold, where we'll give the opportunity to ask questions of our presenters. So I'd now like to hand over to the President of the Institution of Agricultural Engineers, Mr. Steve Constable, who will give his introductory remarks and also introduce our first speaker.
Thank you, Charlie. So the United Nations Food and Agricultural Organization suggests that the average person in the world consumes approximately 675 kilograms of food per year, or 1.85 kilograms of food per day. The USA and Canada consume the most at 861.8 kilograms per year, and Africa is the lowest at 540.8 kilograms per year. If we then consider the suggested global population increases up to 2050 and beyond, then it's reasonable to suggest that the global agriculture system will need to increase production by a further 1.35 billion tonnes per annum to maintain the current level of food availability over the next 25 to 30 years. From the average consumption data, there's a school of thought that redistribution of the current excess food availability to the poorer nations should be accelerated, especially as the wealthier countries' populations are static or slightly decreasing, and the poorer nations are increasing at a pace. However, this will not be enough to meet the increasing demand. As engineers and academics in all land-based disciplines, it is our responsibility to be aware of the current challenges, whether it be climatic, environmental, political, or physical, and offer solutions that meet those challenges to reduce hunger poverty in all areas of the globe. As Charlie's mentioned, our conference today is titled Agricultural Engineering Feeding the Future, where our expert guest speakers will examine various exciting developments aimed at helping overcome these challenges. So without further ado, I hope that you find today informative and interesting, and thank you for attending the Institution of Agricultural Engineers 2023 Landwards Conference. I'd now like to hand over to Will.
Perfect. Okay, good morning, everyone. Thank you for the introduction. To start off with a wee bit of an introduction about myself, my name is Will Downie. I work for John Deere UK. I'm a precision ag specialist for the business, so I look after the area of Scotland and the west of England, so from Carlisle down to Wales, and supporting our dealers with all of the precision ag technologies which we offer to our customers. And really, I think we've seen in John Deere a big trend in this, in particular the last 20 years of our production of precision ag technology, in the last 5 years of our advancements in technology. And again, when we look forward to what the next future has, we really are trying to see how better we can support our customers with our technology. And today I want to just give a bit of a quick overview as to what we are offering and what we are doing in the space of precision ag technology to, as you say, make our food a more resource and help with the efficiency and sustainability for our customer base, okay? And one thing I'd particularly like to focus on is our recent product, which we have just launched around our NIR analysis of grain. So being able to take data-driven decisions from arable crops in the field and use this information in other parts of the production cycle for a farmer. And to start off with, I think as we're all aware, things are changing rapidly. We have a demand from agriculture that we need to produce more food. There's more population which we need to grow this for. But I think the other side of it is we need to produce this food in a more sustainable way, and we need to be able, as farmers, to be able to also document what we do and show the general public that actually what we are doing is an efficient way and a sustainable way of making food production within the UK and across the world. And at John Deere, we have always been at the forefront of this, and it's one thing which is particular, which we have a big focus on, is sustainability of also food production. And within agriculture, things are changing very, very, very quickly. We look at the space of autonomy. That's changing very quickly. What will happen in the next 5 years in the UK? I'm sure there's a lot of things to happen with our own products and other products on the market. Sustainability, customers are wanting to do more with less inputs, with less input costs. So again, that's a huge part of it, which is our kind of key focus of our business. And that leads us on to what our leap ambition at John Deere really is. And as you see on the screen, we really are wanting to provide a service to our customers to allow them to have the economic and sustainable benefits which they can have. And by this, we truly believe this is through the advanced technologies and solutions which we as John Deere can provide, and also our dealer network to the customers. So again, we focus on producing and engineering new products all the time, from bare iron and producing new tractors, new combine harvesters, new forage harvesters, whatever it is. But what we see the trend of is that the technology we need in all of these products is the same throughout each production cycle. And we really want to harness the technology which we fit in these machines to ensure customers to be able to be more sustainable. And I think the issue we always see across the whole industry is that we're always very, very good at creating all of this technology for customers, but how can they actually use this, and of what benefit is it to them? Yes, we can gather all this surplus of information, but 9 times out of 10, most customers don't really know what to do with this information, and it just gets put in a drawer somewhere and it's never really used again. And that's been going on in the industry for, I think, quite a long time. And again, this is why we have had a bit of a change in how our business of John Deere globally works, and particularly within the UK and Ireland, of being able to help customers and educate them, and farmers and growers and institutions like this, as to how we can better make use of data. And that's what I'm going to kind of maybe frame this presentation around. And to do this, we had a bit of a reorganization within our business and tried to work more on what we call production systems, because typically when we look on the left-hand side, what we do in for instance, the small grains industry. So when we grow a cereal crop, the technology we need is the same throughout, but the technology that we use in the cereal crop is very different to what a dairy farmer might use for producing his silage crop. Hence why we've tried to really split these into production systems, so we can then produce a solution which fits the customer for their best form of production cycle. And typically, as we see in the middle of the screen, this is the kind of approach we take. There's always an element of managing. So we need to be able to offer the solution to the customer to manage their production systems. But typically, it always starts off with the preparation of the field, the planting of the crop, the application of the fertilizer, and finally, the thing we all look forward to, which is the harvest of this crop. And when we talk about precision agriculture, we can offer so many solutions. That might be some section control applications, variable rate applications, being able to monitor our fuel progress throughout the field. All these little things is what we believe actually gives us our precision side of a solution. Not just having one product that's going to do everything. I think being able to get 1% from being able to monitor your fuel performance, another 1% from saving on your seed costs, maybe a 5% from saving on your application costs, and then maybe a further 10% for the next production cycle from analysing our harvest costs, because we've taken in that harvest data, and then suddenly we know decisions we need to make next year. So actually somehow taking all of those little percentages across each production approach might then suddenly give us our 15% efficiency boost for the next year's crop. So that's the kind of framework around how we are trying to work our precision side of our John Deere business. And obviously there is a lot of technology which comes into that. I don't want to touch too much on the basics of, or the technology side of it, but what I kind of want to show you here is how we see our John Deere Precision Ag system. So typically when we talk about Precision Ag and John Deere, it's typically been around being able to have auto steer on a tractor or perform an element of machine control. But really how we see our platform now, which I will dive into in a wee bit in the next slide, is actually offering a solution to the customer and to the industry, which allows them to input their information from their connected advisor. So if you look at the top half of this screen, we're able to maybe, for instance, take in the data that the agronomist has sent to the customer or the plans which their advisor has sent in. We're able to then carry out this performance through the production cycle. So set up the equipment correctly, send the job to the machine, manage and monitor the machine as it does the job, take all this data which the machine takes or records from its system, and then actually analyze this performance within our John Deere system. Once we've analyzed the performance and we've saw the data we need, we then export this back to our connected software company. And at John Deere, we believe that we are not agronomists. We are not the ones which are going to educate customers how to farm better. What we want to do is give them the solutions, the technology, and the skill that they have the ability to also do this with other platforms. So we talk about the John Deere Operations Center, which I'll speak on the next slide, but that is our core to our data management facility. And that is a complete open API. By that, I mean any company can connect with this software. Any company can then input their information into this and also connect with the John Deere system. And along the bottom, we also show some of the technology that is also required for us to get our customers fully connected. So typically this is to give the connectivity within the tractor, have our display, the operator interface, which the operator uses, get a GPS signal into the machine, and then finally it's all harnessed by what we talk of our operations center. A quick overview of what this does. So this is our machine management portal. This is in base on every single John Deere product you can buy today. So all the way from a small turf mower in the turf industry, all the way up to one of our biggest tractors, combine sprayers, harvesters, whatever it is. Everything comes in base for free with our Operation Center platform. And this can do all of your management for your farm. So having all of your field boundaries in this field, all of your guidance lines, all of your machine information, its hours, its servicing, its intervals. But also the biggest thing we see from this is the documentation, because typically, as we know, agriculture gets a bad press at times for documentation of applications, knowing what we've done, where we've done it, and when we did it, and how we did it. But this solution here sort of takes care of all that, because whatever operation a tractor or a machine does in the field, everything is documented in one place. And that's really what we want from the Operations Center, is to have all of our on-farm activities documented within one resource. But this is not just restricted to John Deere products only. So we offer this solution to all other kinds of manufacturers by connecting them with our connectivity packages. So we can have any brand of machine connected using the Operations Center to manage all of their data in one place. And that's what we want to offer a solution to our customers, is that they can have a solution which they can manage their whole farm off and have all of their information in one place. Because we know ourselves in our personal life, if you've suddenly got an Amazon Prime account, a Netflix account, a Disney Plus account, and you're sitting on the TV trying to figure out which one to watch, and you've got to scroll through every single one of them and then look at the TV and whatever else, it's a bit of a pain. And it's the same in agriculture. We want to offer a solution where it's your one place where you can go and analyze all of your machine data. But also, when we look at the sustainability part of our Operations Center, we're doing a lot of advancements in how we analyze machine performance. And a big thing now, when we look at, for instance, the example I've got on the screen here is the fuel emissions. So we're now able to measure the fuel rate, which we've always done, but also analyze the amount of emissions which this has given out for a particular tractor. We're able to then look at across our fleet and analyze the average fuel emissions rate across every single machine. This in the future will allow us to then perform a form of sustainability report. So we can look at each machine, and we can look at our farm, and we can look at all of the documentation we've done, take the key elements of data out of this, and actually give us a form of how sustainable production am I actually producing? Am I doing it in the correct way for the correct application types? And that's really where our advancements with this portal is going. You know, we're not wanting to be an agronomic advisor. We're not wanting to be a profit center to understand the farm's profitability, handle its costings. That's not what our focus is, but our focus is actually gathering this information and then using it for other elements. So the example which I'd like to give of that is when we move on to our next topic. And as we all know, when we look at the challenges that we find, we have to have nutrient use in crops is a huge thing. So this is an element which we need to also harness, and we need to reduce the amount of nutrients which we use on our farm. And that brings to the whole sustainability and making us a sustainable food production approach. And a lot of this is done to the two key things you can see on the right-hand side of the screen. It's being able to apply precise and adjusted fertilization without nutrient losses, and being able to document that and use that information to further help your advancements along the production cycle. And when we look at agriculture and we look at fields in particular that customers grow on, every single field is different. So being able to take a broad brush approach of that, actually, when we look at my 50 fields that I farm, I'm going to do the same application on the same field at the same time. It just quite typically doesn't work, because we've got different forms of elevation in the field. We've got different levels of organic matter. Soil texture can completely vary in between fields and also within fields. And also the nitrogen is a big part, because depending on the soil structure, the organic matter, where this is, the amount of rainfall, obviously the nitrogen level is obviously different. So actually, when we put all of these pieces together, we somehow get a huge amount of in-field variability when we look at our fields. And again, being able to manage that is obviously very, very, very difficult, because how can you know that actually in that field behind the farm, this area is X elevation, this area is X organic matter, the nitrogen level in this field is X. You don't really know until you've measured it. Being able to measure it and document it is one thing, which we are very good at in the industry. But then how do we then better use that information further along the line? So one product which we look at in particular, which has had a lot of advancements in the recent years, is our Harvest Lab sensor, which we fit onto machines. This is a NIR sensor, so a near infrared sensor, as you see in the top of the screen. And this uses the form of light technology to analyze the crop as it passes through this, okay? So this can be used in lots of different elements across the agricultural production cycle. So we've typically had this as a feature launched on forage harvesters for doing constituent sensing of the crop going into a forage harvester. So we can then see the sugar levels of crop, the ash content within the crop, the MP and K values, all that sort of thing, which we can then use that data for the next step. A thing we've seen very popular in the last year with more restrictions on NVZs within the UK is being able to analyse the slurry manure going through our machines and what we're applying onto the ground. So we're then able to also document the nitrogen, the potassium and the phosphate elements onto a field. So we've got a true documentation level of what has been applied to that field in what place, even down to the point where I can set a set limit that on this field, I want to apply 50 kilograms a hectare of nitrogen, and the machine will completely automate itself. So really, really good technology, which we've got there. But most recently, we have just launched the ability to do grain sensing on combine harvesters. And that's really what I want to kind of talk a wee bit more about. And what does this actually do? So being able to do grain sensing on a combine harvester allows us to measure the constituents of the crop. So we look in the UK, the most applicable at the moment will be obviously our wheat, our barley, and our rapeseed crops, as we can see in this chart. And what we can measure from them is our moisture, protein, starch levels for wheat and barley, but also in rapeseed, we can also measure the oil content within the crop, okay? What does this mean to us in a simple way? So being able to measure moisture, yeah, we've been able to do that for many years. Being able to measure protein in the crop and starch, we can do that, but it's always on an individual lab basis. So being able to actually analyze what goes through the crop or what goes through the combine in a particular place of the crop is obviously very, very difficult. Hence why this is where this system could come in to help us by analyzing our protein level and starch level of the crop as it passes through the combine. And I will explain of what use protein data is in a short period. But being able to measure our crop gives us lots of benefits because we're able to first find out the quality of the crop. So very much with combine harvester have been based on finding out the quantity, so knowing a tons per hectare, what is our yield from this crop. We've always been very good at that. But actually being able to achieve the quality helps us in lots of areas. So particularly for marketing the crop, so for achieving different pay brackets for when we sell our crop. So is it going to make milling wheat or is it going to make feed wheat? We can distinguish that now. But the big thing is our optimized nutrient use, because by measuring the protein value in our grain, we're able to understand what was the nitrogen removal from that crop, okay? And we have got real-time information. So being able to harvest and measure the crop on the move, on the combine harvester, and allow us to have, a typical approach where previously we would just measure a sample in the laboratory. We would only then have one data point for every 2 to 4 hectares. You're taking it in large trailer volumes. You didn't really get a very accurate representation of what the value actually was. Whereas when we fit this onto the combine, we've got a lot more measurements. Actually, now even down to half a second, we're getting a data point off the combine. So our amount of documentation we're taking in is a lot higher. And then how do we use the data? And this is what I want to talk about. So as I discussed, by measuring the quality, we're able to use this for logistics and marketing of our crop that we harvest, but also being able to plan for the next season. How much nitrogen efficiency have we used? Can we use this data to make ourselves more sustainable by using less fertilizer in different places? And we've done a lot of tests and experiments in the last year harvest, so for the 2023 harvest around the UK, and actually the results we found by doing different trials and applying different elements of nitrogen onto different fields has been incredible. And actually, you always think that by putting the most nitrogen on, you will have the highest quality and the highest amount of yield. It's never the case. Because when we look at this map here, we always see a huge variation between yield and protein, of course, because protein allows us to have high quality crops. And what we can see here on the screen is we've got a picture on the left of our yield documentation and on the right of our protein documentation. Instantly, on the left-hand side, we can see the area, which is our red, lower yielded area, is actually where on the right-hand side, we have had a large protein analysis. So by doing this, we can instantly see a correlation that where there is low yield protein, low yield documentation, there's very high protein documentation, okay? So that's some quite interesting facts that we've found, and typically we see a very big trend when we look at customers' data with this. For instance, we might be seeing that on every tram line within the field, we've got very, very, very low protein but high yield. This is maybe because the customer's fertilizer spreader wasn't set up correctly. So when he was spinning down his tram line, he was getting a very much high level of yield but low protein because it wasn't set up correctly. Just to understand what we can use of this data, so the protein level that we look at is actually an indicator of the nitrogen offtake that we've taken from that crop. Okay, so that will measure that in kilograms of nitrogen per hectare. The chart on the right is quite simple. Basically what we're showing down the left-hand side is the yield of the crop at 14% moisture. And at the top of the chart, we're showing the protein level. So what we're saying here is when the protein level is at 10% on our 9 tonne a hectare yield crop, we're harvesting 136 kilograms of nitrogen per hectare. Whereas when our protein level is at 15%, we're actually measuring taking away 203 kilograms of nitrogen per hectare. But without measuring that when you're harvesting the crop, you will never know these figures. So this is where we get into the next level. So again, on this screen here, we show two different elements. Okay, so this is just our typical things that we look at within an arable crop. And what I've done here is create a wee bit of a table to kind of explain it. So we have our field average. So that's our way of not measuring anything, just taking a sample from each trailer load. And we can see here that actually we have got a pretty consistent variation. Whereas on the right-hand side, this is the information taken from using our Harvest Lab sensor. And you can instantly see such a huge variation in data throughout one field. So this was just taken off of a 10-hectare field, and instantly we can see that actually across the field there is a huge variation. And that's really where we want to use this data in a more precise way, because by taking in individual field samples versus being able to analyze everything on the move, we have got a far better representation. So from this, where would we then use this data? So if I know that I've actually got within the field a very low area of protein, well, that therefore means I need to maybe top that up with an extra element of nitrogen, or the other side of the field is very, very high has very, very high protein. Well, do I need to actually apply as much nitrogen onto that the next time? So again, that maybe then therefore saves us in the next production cycle, that after our 2023 harvest, when I go into 2024 harvest for this 10-hectare field, instead of me as a customer or farmer having to purchase, for instance, 10 tons of nitrogen for that field as a broad brush, I might only need to then apply 6 tons. So therefore, there's a sustainability benefit because I'm not applying as much nitrogen onto the crop. Also for the customer, there's a huge cost saving because we know the price of fertilizer today is very, very high. We can then reduce our fertilizer use across this field as well. And some interesting situations here we see on this map. Again, we look at our yield protein on the left and our yield on the left and our protein on the right of the screen. We can instantly see a variation between it. So what we can also see here by applying different forms of manure onto fields is that actually, depending on the type of manure which you think you're applying, you can have different levels of protein. Once we've then adjusted our optimum use, we know that actually we need to apply a different level. We can then instantly within the John Deere Operations Centre, we can then perform our agronomic maps. So we can then import our variable rate maps for that field. And as you can see on the screen here, by wirelessly sending these to machines, we also offer the customer a solution to maybe then transfer these maps directly to the machine. So our operations center for our small grains production cycle can do all the way from mapping the field at cultivation all the way through to applying it or harvesting the information and applying that onto the next year's kind of cycle. So I hope that kind of makes sense around the protein sensing element. There's a lot of information which we need to cover in quite a short space of time here, but really what we're trying to show is that we have got a consistent recording source. We're always recording more and more data and being able to use this data and benefit the customer in better areas. And combine harvester technology is always evolving. We're always putting more horsepower into the machine. We're making combine headers bigger. We're making grain tanks bigger. We're making more capacity and more capacity and more capacity. But I think one thing which we need to be very, very aware of is that what is the quality of the data which we are actually harvesting from these machines, and how better can these customers use this data and actually benefit their production cycle for their farming operation. And obviously for us as a business, all of this technology which we are gathering also makes us ready for the future. So we look at some of the advancements that we've got coming, and without doing without doing proper documentation and knowing what our fields are and knowing what it's capable of, when we go on to the next level of autonomy, which we see here on the screen of our see and spray system. So this is using a targeted approach where we only spray essentially what we see within the crop. Therefore, by having this extra layer of data that maybe our harvest lab sensor has given us of the protein of the crop, or being able to map from our see and spray system, we can then map the actual weed documentation within the field. So we've there on our platform got a map showing the variation of weeds within the field. We can then better farm our crops. The main benefit of this, again, for sustainability is reduced amount of application of fungicides, pesticides, etc. So again, we move on to the other element which we talk about of autonomy, and again, having all of these fact-driven decisions and documentation which is gathered, again, makes it possible for us to then run further applications, and we can be able to launch our autonomous tractors into the marketplace and use them in a particular form. And for me, that's really a bit of a roundabout sort of clears up my topic of precision ag and what John Deere are doing in this space. And that's maybe only a very, very small snapshot of the technology that we are using, and in particular the harvest lab sensor to measure protein. But we're always expanding this, and we're always wanting to do more and offer more for our customers. So I hope you found that informative, and I'm open for any questions now or also later in the panel discussion. Okay, so thank you.
Thanks, Will. That was great. There are a few questions in the chat. Can you see the chat, or do you want me to read them out?
Yes, can. Maybe you could read them out in order.
So the first question, we've probably got a couple of minutes. The first question from Danielle. Technology is only as efficient and useful as the ability of its owner to use it. What support do you provide to farms on usability?
Yeah, good question. And that's what we see every single day, is that we can produce all of this technology and offer customers it, but without training them, we do not have a solution. So actually, one thing we've very focused on at the moment is getting our dealers to do a proper training solution for their customers, so that when they buy a new machine, they are trained to a certain level within a John Deere standard, so that they fill in the correct almost paperwork and they do a correct handover. But also a lot of our dealers within the industry now offer training sessions, optimization visits within the winter time, so that they sit with the customer and slowly go through step by step how they can use this data. So that's a very much forefront of what we want to do.
Okay. Next question is from Tim Chayman. I note that your field variability does not include traffic intensity, which can have a large impact on soils and crop yields. With an input of wheel data from the machine, this data should be reasonably easy to add and display in visual form. This would immediately alert the farmer to areas of high intensity and its impact to respond to them. Yeah, very, very good question. And we do see a lot of customers now with that element using variable rate cultivation, so soil compaction maps. So one element that what we can do within our system is analyze the fuel usage within the field. Typically, the fuel usage will then give us a representation. If we're cultivating at a consistent depth, we'll actually, where is our different levels of compaction due to how much fuel the machine is used. From this, we can then create a map of the field showing the different elements of fuel data and import this into our algorithm, which will then, on the tractor's display, show you where your highly compacted areas of the field are. Okay. Question from Alistair Tullock. Interesting presentation. Perhaps worth noting that other companies can provide very similar services. The question is, how much use is typically made of the data by customers? Yeah, very, very true. And at the moment, being honest, of how many customers in the UK and Ireland probably completely use all of the data, I would say is around probably 15 to 20% of what really should be. But I feel that's probably down to, as an industry, actually educating the customer on how they can use this data and what they can do with it,
which is why we've very much got an open approach of opening our system up to as many different farm providers or software providers as possible, so that we can get experts in the fields and agronomists in to actually advise customers on how we can better use this data. And as I said, we are not going to be the ones which are the agronomists and are telling the customer how to use this data. We want to be the ones that can provide this data for the customer and put them in contact with, for instance, their local agronomist, and explain that this is how you should then be using your data.
Okay, just keeping on the theme of data, question from Hugh Crabtree. Data always comes up, who owns data? I think you said access to the operations centre came free with every machine. Is that the offer to farmers so that you can use or even own their data?
Not at all. No, not in a single way. As John Deere, we take data privacy, GDPR very, very, very seriously. And we do not offer a free service so that we can have their data. We offer a free service so that we can let customers actually use their own data, because one thing we typically see is a lot of customers that have to pay to access their data. And in terms of GDPR, when a customer signs up to use the John Deere system, they can purely decide how much data they want to share with their dealer. And typically, as John Deere, we have absolutely no access to the customer's data at all. The only data which, for instance, a dealer will have access to is for helping them in terms of uptime. So knowing when they have alerts in their machine to be able to do proactive servicing and maintenance on that machine. And we take that element very, very, very seriously at John Deere. And we are never using anyone's data in that space.
Okay, I'll just, before we move on, I'll just sneak a question in. You mentioned about systems integrating with other manufacturers. How well do they integrate? I know obviously you see other brands of tractor with Green Star kit on there, but in reality, how well do they actually integrate when you get down to the sort of level of precision that you're talking about? Say if you want to
very good question. And what we can see is when we look at John Deere, we have two levels of what we can offer for a customer in terms of what we can offer into their third party machine, and we keep it as what we call the whole farm value and the John Deere kind of advantage difference. When we talk about basic doing documentation, auto steering on tractors, knowing where that machine is, documenting the data, that always works very smoothly. That element of it is done well. But when we start going into the next level of automation and doing turning of tractors and also harvest lab applications, which I talked about, that is where then the system has not been designed to work on a third-party machine. And when we get to that second level of automation, that's where it's never a seamless approach to having it on a third-party machine. So we always say, if you want to have the John Deere solution, you can use the basics, but when you go to the next level, you have to have used a John Deere machine for that.
Yeah. Okay.